Let us see the Alford-Wegener hypothesis. According to this concept, about 200 to 300 million years ago, all continents were attached together as a single land mass. That single land mass was called as the supercontinent as Pangaea. Thermal expansion and volcanic activities broke the Pangaea into new continents. These new continents drifted away from each other due to further expansion of rift zones. Wegener was the first to use the term continental drift. There are several evidences available on earth to support the theory of continental drift. Similar fossil patterns across many adjacent countries is one among them. The Mesosaurus skeleton, freshwater reptile found in Brazil and South Africa, is another evidence. Land reptiles like Lystrosaurus, fossils from the rocks of same age from locations of South America, Africa and Antarctica are another evidences. Several living animals are being found on different continents even today. The widespread distribution of Permo-Carboniferous sediments in South America, Africa, Madagascar, Arabia, India, Antarctica and Australia is another evidence. The oriented glacial striations and deposits called as stilites in the Gondwana land was another evidence. Similar coal deposits existing in the eastern United States and Siberia is one more evidence to support the theory of continental drift. Rocks of different ages show a variable magnetic field directions. Magnetic north and south reverse through time, which have been seen in different rock types. Initially it was considered as polar wandering, and later it was attributed to paleomagnetism, and finally it has led to the theory of plate tectonics. People mistook the paleomagnetism with reference to polar wandering. The study of paleomagnetism came after these studies. This has provided the geophysical evidences to support the movement of lithospheric plates. The word plate here technically refers to the rock mass which is available on the crust. Early in 1953, scholars have introduced the theory of plate tectonics. Jack Oliver, a geophysicist, provided many seismological evidences for these findings. Continental crust, oceanic crust and lithospheric plates were identified as unique features after this. Scientists believe that below the lithosphere there is a relatively narrow mobile zone in the mantle called as asthenosphere. This zone is composed of hot semi-solid material which can soften and flow after being subjected to high temperature and pressure over a geological time. This rigid lithosphere is thought to float or move on the slowly flowing asthenosphere. This diagram shows the position of asthenosphere in the interior of earth. It illustrates the location of asthenosphere approximately 100 kilometers below the surface and 60 kilometers below the continental and oceanic crust. Lithosphere is broken up into 7 to 8 major tectonic plates and several minor plates. These plates are viscoelastic solid rock bodies. A tectonic plate is a massive irregularly shaped slab of solid rock. The plate size can vary greatly from a few hundred to thousands of kilometers across. The Pacific and Antarctic plates are among the largest plates. Plate thickness also varies greatly, ranging from less than 15 kilometers for young oceanic lithosphere to about 200 kilometers or more for ancient continental lithosphere. Plates ride on the asthenosphere.